In Chapter 2, we will continue exploring the basics of programming in Java. In Chapter 1, you learned how to create, compile, and run a Java program. Now you will learn how to solve practical problems programmatically. Through these problems, you will learn Java primitive data types and related subjects, such as variables, constants, data types, operators, expressions, and input and output. When we begin to solve a problem by writing a program, we must first design a strategy to solve that problem. This strategy is called an algorithm and is a list of steps that we will follow to solve the problem. Consider the problem of baking a cake from a box mix. The directions on the cake mix box are the strategy or the algorithm for solving the problem. If we follow the steps on the box, we will end up with a delicious cake. Similarly, in programming, if we design our algorithm correctly and program it accurately, when the computer follows the prescribed steps, the problem will be solved. Now, it is important that we write out the steps of our algorithm before we start coding in the programming language. When we write out the steps of our algorithm, we will use pseudocode, not Java, to do so. Pseudocode, or not code, is a combination of natural language, English, and some programming code. Pseudocode is not meant to be run on the computer, but rather to guide us in the writing of our program. Consider the problem of computing and displaying the area of a circle. Our basic algorithm would be as follows. Step 1, read in the radius. Step 2, compute the area. Step 3, display the area. This algorithm is coded out in Listing 2.1 in your textbook, and we will now trace the run of that program. As we begin the trace of Listing 2.1, first notice the construct of the program. Every program is a class, and every class has a name that begins with a capital letter. The name of this class, the name of the program, is Compute Area. Also notice the camel case in the name of this program. Every program also begins in the main method. That's our Go square. So notice the main method declaration as discussed in our previous lecture. We will begin the trace of the program with the first statement in the main method. Recall that a statement ends with a semicolon, the statement terminator. This statement declares a variable of type double and names that variable radius. Effectively, what this does is says, hey computer, give me some space so I can put some information in that space. The amount of space that I need is enough to hold a double, and that's a key word in Java. We'll get into what that means a little bit later. And call this space radius, so that when I refer to radius in the future, you know to go to this very address, this space in memory, and get the information contained there. Likewise, the next line in the program declares a variable of type double and gives it the name area. Essentially says, hey computer, give me some space in memory, enough to hold a double, and call that space area, so that when I refer to area in the future of my program, you will know to go to this very memory location and access the information there. This line of code represents an assignment statement in Java. The assignment operator is the equal sign. What the equal sign does is it takes the value on the right-hand side of the assignment operator, the equal sign, and places it into the memory location on the left-hand side of the equal sign, the assignment operator. In this case, we will be taking the value 20 and placing it into the memory location that we created and called radius. Once again, we have an assignment statement. This assignment statement performs the computation as noted on the right-hand side of that equal sign, and when it is done, takes the result and stores it into the memory location that we called area. Finally, the last step in our algorithm is to display the results to the console. In order to display output to the console, we must use our print statement. Remember, we discussed both the print and the print line statement. In this case, we'll be using our system.out.println statement to display the area for the circle of radius, whatever value is found in radius that the user entered, is, and then the corresponding area. Note in our print line statement that the values that are denoted in quotation marks appear on the screen or the console exactly as they are coded in between those quotation marks. Because the word radius is not enclosed in quotation marks, Java knows that it's actually a memory location, and it must go to that memory location and get the information there and display the information found in that location. Is, once again, is enclosed in quotation marks and is displayed exactly as it appears on the screen. And then finally, area, not closed in quotation marks, will send Java to that memory location and display the contents of that memory location. It's also worthwhile to note that the plus sign is used as a concatenation operator to concatenate or to join those various pieces of information together. Now let us consider the case where we want to allow the user to enter the value of radius instead of hard coding it into our program. It is important to note that if we want to read input from the user, we must have each of these components in our program. Further, it is important to note that we need only to import the scanner class once, and we set up a scanner object once in our program. We do not need a new scanner every time we wish to receive user input. However, each time we wish to receive user input, we will need to prompt the user for the type of information that we want to receive and then read in that information from the user. The 4 parts of reading input from the console are such. First, we must import the scanner class, and we do this before the class declaration that contains the name of the class, the name of our program. We do this using the import statement, import java.util.scanner, semicolon. Import is a reserved word or a keyword in Java. Next, we need to create the scanner object. This is done inside the main method, and we create the scanner object using the scanner declaration statement. We do this using the code found on the screen. Note that we can name the scanner whatever we like. In this case, our scanner is named input, and that's going to become important later when we try to use the scanner to read the input from the user. Once our scanner is set up, then we're able to access and use that scanner to get the input from the user. But before we do that, we need to prompt the user for information that we want. And we do this using, of course, our print statement. And we say, enter a double value. That lets the user know exactly what information we expect from them. And then finally, we're going to use our scanner to read in the input from the user. And we're going to do this by reading the input into a memory location, in this case a variable called radius. Before we can put any information in radius, we have to make sure that that memory location has been allocated. And so to do that, we have to declare its type, in this case type double. We use a method called nextDouble to read the input from the user. Because we're reading a double, we must use nextDouble. Later in the class, we will explore various types of ways to input other data types. In order to use the scanner for user input, we must first import the scanner class from the utility package. There are 2 ways to import the scanner class, implicitly or explicitly. Implicit import uses the asterisk to denote a wildcard. This means that all the classes in the package java.util are imported. Explicit import is specific import, and it specifies a specific single class that is imported from the java.util package, in this case, scanner.